Okay, welcome to this third and final video of this mini-series on Kubernetes on the ThreeFold grid. In this video, I will be creating a couple of more worker nodes that we can deploy our Nginx server on. We will do that by simply altering the contents of our YAML configuration file. Specifically, we just have to increase the number of replicas and Kubernetes will take care of everything else. Okay, so let's get started by looking at what is currently running on our cluster. Specifically, which pods are running in the Nginx test namespace. As you can see, there's currently 2 pods running in our namespace and both of them are running on my test master. Since we have not created any worker nodes during the deployment initially, that's expected. So let's go ahead and do that now. As before, for this testing, a minimal configuration will be sufficient. Our worker node will not be needing its own public IP version 4 address as all traffic will be routed through our master node. Okay, so let's go ahead and find a suitable node in FreeFarm. Okay, no nodes available. Well, then let's just go to Belgium once again. Sweet, we found a couple of nodes. Just choose any for this test and add worker. Okay, that will take a while, so let's just wait a bit. Okay, so while we are waiting, let's just go over to the terminal and use nano to open our YAML configuration file. We can see that there's currently 2 replicas. Let's change that to 4 and save our file. Okay, go ahead, save. Okay, so after a few more minutes, our worker node should be up and running. So let's wait a bit and come back. Okay, so as you can see here, a new worker node has successfully been added to the Kubernetes cluster. So now that we have our worker node up and running, we have to assign some work to it. We can do that by applying our Kubernetes YAML configuration file once again. kubectl apply -f and the file name. Okay, so as you can see, our cluster has been updated with the contents of this file. And in order to see what's running now, let's just execute this command again. And we can see that we have 2 more pods running on our test worker and they are creating currently. So very good. Okay, so let's wait a little bit longer and execute this command again. Awesome. You can see now that our pods are running on our test worker 1. So now we have a total of 4 pods running on 2 different hosts. So each time we access our website in the browser, the load balancer should evenly distribute the work between those 4 pods. In order to verify that this is working, let's have a look at the logs of one of our pods. So we will use the kubectl logs command followed by the name of our pod. And then I forgot the namespace here. So let's add namespace equals nginx test. Okay, so as you can see on the right in the terminal, a couple of requests have already made through their way to our pod. Let's use the F flag to look at real-time log output. Okay, so now we can just reload our page a couple of times and yep, there's a request. And yeah, considering that we currently have 4 different pods, each 4th request should be directed to this pod by the load balancer. Let's scale up our cluster a bit more by adding a second worker node. So we head back to the playground, my test worker 2, just use the same configuration as before, very minimal should be sufficient. And we will select a node in Belgium again. Doesn't really make sense to put it all on the same farm, but for testing this will be fine. Okay, by now you know the drill. After we add something to our Kubernetes cluster, we have to wait a bit, so let's do that. We are back and there is our second worker node. Okay, so let's get over to the terminal, type kubectl get nodes, and you can see test master, test worker 1 and test worker 2 are up and running. Next, we will change the number of replicas again, this time to 5. Okay, 5 and save. Now, of course, we have to apply again. So type in kubectl apply -f and the file name, and our deployment has been updated. Okay, in order to verify, let's check our pods. kubectl get pod -o wide -- namespace equals nginx -test. And now you can see we have 5 different pods running, and one of them, the last one, the newest one, is running on our test worker 2. Okay, so now that we have all the names of our pods, we can just easily look at the logs. So let's copy the first pod right there from our master, right in here, and finish the statement -f minus namespace equals nginx minus test. Let's get over to our web page again and refresh a couple of times in order to see that some of the requests are getting through to this instance. There you go. So now, in order to see how the load balancer is doing its work, let's add a secondary tab up here and look at the logs of a different pod at the same time. So we will just copy the name of some random pod, and in the second terminal window we will use the same command as before to follow the logs of this specific pod. Okay, there you have it. The logs are here. Let's refresh a couple of more times until, yep, there it is. And refresh here. Whoops. Open the logs again and refresh here. Yep, there's a request. Refresh here a couple of times. Yep, there's also a request. So as you can see, the load balancer is working and assigning work to both of the pods that we have looked at. So now finally, let's have a look at a third pod at the same time in a third tab to really showcase this better. And afterwards, we will simply remove one of the pods from our configuration and see that it's still working. So let's get started by looking at the logs of our first or of our last newly created pod, the newest one on worker node 2. Okay, we are following the logs, and yep, also here we receive a request. And back to the other one, and to this one, refresh a bit, and yep, also here. Okay, so we could do this forever and keep looking at the logs and refreshing our page, but I think you get the idea. The interesting part is now what happens if we just delete one of our nodes from our configuration. So without further ado, let's just do that. Delete, delete, okay. And well, now we have to wait a bit in order to make sure that's actually deleted. And once that's done, we will continue. Okay, the break is over, the node has been deleted, and time to look at our pods from the terminal again. Let's do that. Okay. Okay, so as you can see, we still have 5 pods, so everything the same as before. That's because the K3s instance doesn't really know that we have deleted a worker node from the playground. In order to actually remove our node from our cluster, we would have to do this manually using the command line. The good thing is, even if we don't, our website is still highly available, and every time we try to load our web page, it will still work. That's because the load balancer will simply realize that one of the nodes has gone offline and will not assign any more work to the pods running on that specific node. That means it doesn't matter if one of the nodes goes offline, as long as it's not your master node. To conclude, we can see that by making a deployment spread out over multiple nodes, we can make it more available and more resistant to any downtimes. In order to showcase this, I have deleted a node from the existing cluster. Deleting a node this way is pretty much the same as a node going offline completely and being unavailable to your Kubernetes cluster. This could happen for all kinds of reasons. In order to make sure that your workload is still available when this happens, you can use Kubernetes on the ThreeFold grid. This has been my final video on Kubernetes on the ThreeFold grid. This is the first time I've ever done a video tutorial, so please feel free to criticize me. If you liked it, also please be so kind to let me know. Thank you and have a great day.